Hello everyone. Now today we are going to discuss the mirror formula or the mirror equation, and it is the same or holds good in case of all types of mirror that we have come across so far in our discussion. So let's get on to the formulation. Now in that case I would like to bring to your notice three figures that I have taken over here. Now here the first two figures, they are for the concave mirror, and the last figure, as you can see, is for a convex mirror. Now in the first two figures, the objects are placed at different positions. In the first figure 1, you can see for the concave mirror that the object AB is placed beyond 2f, or beyond the radius of curvature, that is beyond the center of curvature. And for that, the image that is obtained is a real one, because the rays are actually meeting after reflection. Whereas in the next figure that you observe, in the next figure we have the object to be placed between the focus and the pole, that is the F and P that I have marked over there. So in that case the image cannot be formed with the real reflected rays meeting, because the real reflected rays they will be diverging after reflection, and when produced backward, they will give a virtual image, that is a dash b dash being the image. Now in all the cases that you can see over there, the naming has been placed the same in all the three figures. The AB in each case is the object, and from that we are considering two rays from the point A, so that after reflection those two reflected rays, when they meet, they will give the reflected or image, or they will give the image of the point A as A dash, and correspondingly the base of it will give B dash on the principal axis. So in that is the same in every case. So in each case the naming has been put in the same way. So two rays that are coming out, one is taken parallel to the principal axis and strikes the mirror, each of the mirror, be it convex or concave, each of the mirror, it strikes at the point M, okay, on the mirror, and then it gets reflected. Because they are parallel rays, they will get reflected through the focus that is taken as F, capital F, right? And they will be reflected along F, or they will be appear to be reflecting from the point F in case of convex mirror that we can see over there at the last. So after reflection it will be observed that it will be coming out of the focus in case of convex mirror. Obviously the focus in case of convex mirror, as I have discussed earlier, is a virtual focus. Now the second ray that we are considering for a ray diagram is passing or is directed towards the pole. There can be multiple number of rays obviously, but we are considering only two of them. So the second ray that I have considered is striking at the pole, and after reflection, following the laws of reflection, it gets reflected in the backward direction. Now in the first figure it actually meets the first ray, that is the parallel ray, and passing through the focus and giving the image at A dash and B dash for the given object AB. And in the second case it is unable to meet after reflection, and that is why they are produced backward, and they give the image at A dash B dash and on the other side of the mirror, of course. And so that is the virtual image that is obtained in case of the concave mirror. And in the third figure, for the convex mirror, you place it anywhere, the object, the rays after reflection, they won't meet, because one of them will be reflected on the other side, while the one directed towards the pole, that will be reflected towards the bottom. So they are obviously diverging, so they won't meet actually, so they have to meet virtually, they have to be produced backward, and in that case they are produced backward to give a virtual image. So far we are clear about the formation of the image in each case. Now as I have said earlier, you must take note of the fact that I have named each and every thing in the figure accordingly. So every point O represents the center of curvature, and every object is represented by AB, the image as A dash B dash, the focus as F in each of the cases, where it is real in case of concave and virtual in case of convex, and the distances accordingly will be taken as per our requirement. So the objects and the pole obviously is at the point P of the mirror, and M gives the point where the rays are striking, where the parallel ray strikes the mirror. Now so as I said, now let's consider the distances. Now every object distance that I have taken is therefore equal to the distance of the object from the pole, that is PB, which is given by U. Okay, as you can see, U has come up, and then the image distance is given by V, while the focal length in each case is given by F, right, which is at the right hand side for the convex mirror. And then finally you have the object size of the object as O, which is given by AB, the vertical length, and all these previous lengths are horizontal. Obviously, as you can see, U, V and F, they are horizontal, and the vertical length of the object is given by the size of the object is AB, and that of A dash B dash is I. Now before moving over to the derivation, let's consider sign convention. Now what are these sign conventions? If you see, now sign convention helps us in understanding or knowing about the position of the object and the image correctly. Now obviously we know the position of the object, but what about the image? Now let's consider the Cartesian coordinate system with two axes. Now in those two axes, if you consider the pole of the mirror to be coinciding with the origin of the Cartesian coordinate system, then all the distances, that is U, V and F, that we have taken will be along the x-axis. Obviously they are along the x-axis because they are taken the length along the x-axis. Now their distances can be therefore taken as positive or negative depending on which side of the pole they lie. For example, an object usually lies to the left side of the pole of the diagram that we have taken. In all of them you can see that. So the object distance U here, according to the sign convention, can be taken as negative. Now when do we take them as negative or positive? We'll be just approaching that in a short while deriving the formulas. And similarly, the focal length will always be negative for a concave mirror, while it will be positive in case of a convex mirror, because the focal length is towards the right in case of convex, so obviously positive x-axis. And while considering the size of the object or the image, we take the vertical y-axis. Now as you can see, the curly braces over there, they indicate that as the object is erect or upright, the size of the object is O and is taken as positive. While in the first figure, if you notice that the image that is obtained is an inverted one, so in this case the inverted image, the size of the image is I, but it will be taken as negative. So it is the size of the object or the image size wise is considered along the y-axis. So basic summary of the sign convention that we just considered is that the vertical lengths are taken along the y-axis and the horizontal lengths are taken along the x-axis, with the positive or the negative signs that are indicated with respect to the origin or the pole. So if they now if you see that coordinate system taking from the right top corner, both the axes are positive, then going anti-clockwise, the x-axis is negative while the y-axis is positive, and then negative negative, and then positive negative. So in each case we are considering the curvature of the mirror to be very negligible. Okay, so as the objects are at finite distances, so the rays are almost paraxial. Okay, so the parallel rays that we are considering from the point A to the point M, they are paraxial, of course. So the length MP can be taken as a straight line. Now consider the triangles ABP and A dash B dash P. They are similar. Now how are they similar? Now you can see that both are right angle triangles, and the angle of incidence I is equal to the angle of reflection as per the laws of reflection. So we have APB to be equal to angle A prime PB prime. So both these angles being same, the third angle has to be same in both the triangles, and hence they are similar by angle 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 axiom. Now take the ratio a prime b prime by ab is equal to pb prime by pb. Now again, uh, consider other two triangles. Now they are a prime b prime f and mpf. They are also similar. Now how are they similar? Of course, you can notice that MP that I have taken is a straight line, considering the curvature being very small and paraxial rays. So angle B prime FA is equal to angle MFP. It will be better for you if you draw that as I draw these figures and consider them. So they are vertically opposite angles which I have indicated, and then they are also right angle triangles, because the MP is a straight line and AB is obviously on the principal axis. Now from that similarity we get that A prime B prime by MP is equal to B prime F by PF. Now MP is obviously nearly equal to AB, because the parallel rays from A strikes the point M, so MP is nearly equal to AB. So from that we have A prime B prime by AB is equal to B prime F divided by PF. Now comparing equations 1 and 2, as the LHS is same, the RHS has to be the same. So PB prime divided by PB is equal to B prime F divided by PF. Now this is equation 3. Now before we move further into the derivation, the equation 3 is very important, but I would also like you to take a note of the first equation, equation 1, that will be used later. Okay, so we'll come to that, how it will be used. It will be used for magnification. Now consider the first figure, figure 1. PB prime divided by PB. PB prime is the image distance and PB is the object distance, and both will be following the sign conventions. Being on the left hand side, they will be negative. Now PB prime minus PF instead of that, so minus V minus of minus F divided by minus F. Putting all these together, we have V by U is equal to V minus F divided by F, and finally we come to the formula where VF plus UF is equal to UV. Now after getting to this point, we will be dividing both the left and the right hand sides by the factor u, v and f, so that we can get vf plus uf divided by uvf is equal to uv divided by uvf. So separating the left hand side, we have vf divided by uvf, uf divided by uvf, and uv divided by uvf. Now vf, uf and uv, they can get cancelled out with the denominator, and we can have 1 by u plus 1 by v is equal to 1 by f, which is the required mirror formula. Similarly, by applying the sign convention on the third equation for the other cases, that is the figure 2 and the figure 3, we'll be getting the same mirror formula, that is 1 by u plus 1 by v is equal to 1 by f. I hope you can try them considering the figure, and you're clear with the concept of sign conventions, then you can do them easily. Then let's get back to the equation 1, as I had told you to take a note of that. A prime b prime divided by ab is equal to pb prime by pb. Now in magnitude, a prime b prime is the size of the image, ab is the size of the object. So this is the size of the image by size of the object, which gives us the magnification of the object, with magnification of the object. So how it has magnified itself, that is what we need to find out. Now this ratio I by O is the magnification, but in the figure, if you see in the figure 1, the I with the image being inverted, the size of the image will be taken as negative following the sign convention. So A prime B prime by AB is equal to minus I by O. So minus I by O is equal to, consider the sign convention again, minus V by minus U. So I by O, that is the magnification by definition, is equal to minus of V by U. We get that from the above formula. Now by similar use of sign convention for from the equation 1, in case of figure 2 and 3, we'll be obtaining the same value of magnification. You can check for yourself. Okay, you can check for yourself, and if you find it difficult, you can comment me and I can help you out, I hope. But it's easy, it's quite easy to find this formula, that is m is equal to minus v by u, and the mirror formula as well. Hope you have understood it well. That's all. Thank you.